You've eaten it grilled, raw, smoked, and maybe even tossed into a salad. But have you ever stopped to wonder where that slice of pink perfection actually comes from? Here's a strange fact. Salmon can swim across oceans, navigating thousands of miles, just to return to the exact riverbed where they were born. It's an instinct so precise, it makes GPS look clumsy. But in today's world, salmon rarely get to complete that journey on their own. In fact, over 70% of the salmon people eat isn't caught wild anymore. It's farmed, raised from egg to adult in high-tech systems that look more like a science lab than a stream in Alaska. And yet, despite being a staple in kitchens around the world, few people have seen what really happens behind the factory doors. How does a microscopic salmon egg turn into a boneless, skinless fillet? How do machines, biology, and AI come together to control every single aspect of a salmon's life? Today, join FactoryX as we pull back the curtain on an industry worth over $20 billion a year. It's an operation that starts in darkness, with fertilized eggs no larger than a grain of pepper, and ends with robotic arms slicing fish to exact measurements, faster than the human eye can follow. What's even crazier, none of this could happen without understanding how to replicate nature itself artificially. Let's start where all life begins, at the egg. The birth of a salmon, where life begins in a tray. At first glance, a salmon hatchery might not look like much. Sterile white walls, trays filled with gently flowing water, and the soft hum of machines. But beneath that simplicity lies a carefully calibrated biological orchestra. Everything begins with broodstock salmon, fully grown males and females raised in controlled environments until they're ready to reproduce. These fish are selected for strong genetics, high survival rates, and ideal growth potential. Once mature, they're gently handled and separated. The females are checked using ultrasound to monitor egg development. When the time is right, the eggs are extracted, not through natural spawning, but manually to ensure consistency and control. It's a delicate process. A single mature female can release up to 5,000 orange-colored eggs. These are quickly mixed with milt, sperm from the male salmon, in a plastic basin. Unlike in the wild, where fertilization is left to chance, here it's conducted under strict timing and temperature conditions. Each second matters. The goal, to fertilize as many viable eggs as possible before cell division begins. Once fertilized, the eggs are placed in dark, oxygen-rich incubation trays. The temperature is typically maintained between 6 to 8 degrees Celsius, 43 to 46 degrees Fahrenheit. Why so cold? Because salmon, by nature, develop slowly, and that's a good thing. Too much heat, and you get malformed embryos or dead eggs. Too little, and development grinds to a halt. But here's the shocking part. The success of an entire salmon farm can hinge on what happens during these few early weeks. Any contamination, fungus, bacteria, poor oxygenation, can wipe out tens of thousands of eggs in a day. So hatcheries often use UV sterilized water, closed-loop filtration systems, and 24/7 surveillance, just to keep these tiny lives alive. After about 250 to 300 degree days, a measurement that combines time and temperature, the eggs enter their next critical phase. Small black dots appear inside the eggs. These are the eyes of the alevins, the first visible sign that the embryos are developing correctly. At this stage, many farms perform their first culling, removing any underdeveloped or unfertilized eggs. Then, around the 4 to 12 week mark, depending on water temperature, the eggs hatch. And what emerges is odd. The newborn salmon, called alevins, don't look like fish at all. They're tiny, translucent creatures with a bulbous orange sac hanging beneath their bodies, the yolk sac. This yolk provides all the nutrition they need in their first stage of life. At this point, they don't even need to eat. The hatchery must keep them in complete darkness and still water. No distractions, no light, no predators. They're essentially newborns suspended in time, floating in trays until the yolk sac is fully absorbed. It's a race against time. If the yolk runs out before the alevin is ready to swim, it dies. But if everything goes well, they'll graduate to the next stage, fry. Before that happens, the farm managers carefully monitor the health of the tank water, constantly checking for ammonia levels, oxygen concentration, and temperature. Some hatcheries even install real-time monitoring software that can detect when a single tank is trending toward danger, sending alerts to smartphones for immediate human intervention. And it's not just about survival, it's about selective survival. The best farms sort the newly hatched fry by size. Why? Because salmon are natural bullies. If a small fry gets placed in a tank with larger ones, it may get starved, injured, or even eaten. Grading machines or manual siphoning helps separate these fish into different growth groups to keep competition fair and growth rates optimal. From this point on, the journey becomes more complex, more industrialized, and more intense. As the fry begin to swim freely and eat commercial feed for the first time, their transformation accelerates. Muscles develop, color darkens, stripes appear on their sides like miniature tigers. They're no longer helpless. They're evolving. These small tanks, no matter how well maintained, are not the end game. The fish need space. They need a taste of the wild, or something close to it. And that's where the sea cages come in. From yolk to youth, the transformation from fry to smolt. Once the yolk sac is gone, the fish have no choice. They either swim or sink. This is the moment when the salmon officially become fry. They begin moving independently through the water, exploring their surroundings, searching for food. It's one of the most vulnerable phases of their life, and it's also one of the most closely monitored. The fry are moved into larger indoor tanks, often made of fiberglass or concrete, where their environment is obsessively controlled. Each tank holds thousands of fish, yet every detail, water flow, oxygen levels, lighting, and feed, is customized down to the decimal point. Why so precise? Because salmon are extremely sensitive to stress. One sudden light change or a temperature dip, and entire tanks can stop feeding, or worse. The transition to solid food is a critical milestone. Commercial feed is gradually introduced, tiny, nutrient-rich pellets made from fish meal, oil, and plant proteins. But this isn't just about shoveling in feed and hoping for growth. Farms now rely on machine learning and automated feeding systems that detect how actively the fish are feeding and adjust accordingly. If fish slow down, the system pauses. If they're aggressive, it feeds more. Every uneaten pellet is wasted money and a risk to water quality, so the system learns fast. As the fry grow, their bodies begin changing. They develop distinctive par marks, those dark vertical bars on their sides, and their fins begin to sharpen and lengthen. This is nature's camouflage in freshwater environments, but in a controlled tank, it's a visual sign they're thriving. At this point, the fish undergo regular grading. Using machines or manual sorting, the fry are grouped by size and health. The fastest-growing fish are often kept together to optimize tank use, while weaker or underperforming ones are culled or moved to slower-growth tanks. And here's something most people don't realize. Salmon, like humans, are vaccinated. But instead of swallowing pills or getting oral drops, they receive individual microinjections, tiny doses of vaccines that protect them from common diseases like furunculosis and infectious salmon anemia. Yes, each fish is vaccinated by hand or robotic arm. It's painstaking, but essential to prevent deadly outbreaks later. By the time the salmon reach 10 to 15 centimeters in length, they're ready for their next big leap, both biologically and geographically. They're transitioning from freshwater to saltwater, a process known as smoltification. In the wild, smoltification happens gradually as salmon migrate toward the ocean. Their bodies adapt internally, changing how their gills and kidneys process salt, shifting their metabolism, and altering their skin color to a silvery sheen. It's an extraordinary transformation, and in farming, it has to be artificially triggered and supported. How do they do it? Lighting schedules are manipulated to mimic seasonal changes. Gradually increasing the hours of daylight inside indoor tanks tells the salmon's body, "Get ready, we're heading to the sea." Meanwhile, mineral balances in the water are adjusted to help train their systems to tolerate saline environments. Once smoltified, the salmon are ready for the real world, or at least a high-tech version of it. The next step is transportation, and that's a logistical puzzle of its own. Massive water tank trucks, equipped with oxygen systems and shock absorbers, are used to move the fish from hatcheries to sea farms. These mobile fish carriers look like something out of a science fiction film, but they're essential. Every bump, temperature fluctuation, or oxygen dip during transport can be fatal. So the trucks are monitored in real time, often connected to a central control center, tracking everything from water pH to oxygen saturation. After hours on the road, the smolts finally reach the ocean, or more accurately, a floating fortress in the sea. These are the sea cages, vast underwater pens that drift in the open ocean or large fjords, anchored to the seafloor. From above, they look like simple floating rings. But underwater, they house tens of thousands of salmon in structures that reach depths of up to 50 feet. And here, things really start to scale. This is the phase where salmon pack on weight fast. They can grow from just 100 grams to several kilograms in under 18 months. But with that growth comes risk, disease, parasites, overcrowding, and environmental waste. That's why this stage is supported by some of the most advanced technologies in aquaculture. Underwater cameras continuously scan the cages, analyzing fish behavior and detecting early signs of distress or illness. If a salmon begins swimming erratically or lags behind, it gets flagged. Some systems can even detect injured or dead fish automatically, triggering alerts for human intervention. And it doesn't stop there. IoT sensors float within the cages, constantly measuring salinity, water temperature, and dissolved oxygen levels. This data is streamed live to farm managers and algorithms that control automated feeders. If oxygen levels drop, feeding slows. If temperature spikes, aerators kick in. It's a symphony of machines and biology working in perfect, silent coordination. But not everyone is impressed. Environmentalists argue that open-net sea cages can leak waste, antibiotics, and parasites into the surrounding ocean. Escaped farmed salmon, sometimes called aquatic fugitives, can disrupt wild populations by competing for resources or interbreeding. It's an ongoing debate that the industry is still trying to solve. Still, most of the world's salmon comes from this method. And when the fish finally reach their target weight, usually around 4 to 5 kilograms, they're ready to be harvested. But harvesting is no simple task. It's a race against the clock, because once a salmon leaves the water, the countdown to spoilage begins. Harvesting the salmon, from ocean to factory floor. After months of careful growth, the salmon in the sea cages have reached their prime size, usually between 4 and 5 kilograms, or about 9 to 11 pounds. But catching these slippery, fast-moving fish is no simple chore. It requires precision, timing, and technology working in perfect sync. When the day of harvest arrives, the operation begins quietly but efficiently. Large nets are deployed to corral the salmon toward a central collection area inside the cage. This process must be done carefully to avoid stressing the fish. Stress releases enzymes that degrade flesh quality and shorten shelf life. Once grouped, salmon are gently scooped up using specialized pumps or cranes equipped with soft nets designed to minimize injury. Injuries mean bruising, and bruising means less fresh-looking fish for consumers. The fish are then transferred into specially designed transport tanks aboard boats. These tanks are filled with clean, oxygenated seawater kept at optimal temperatures, mimicking the salmon's natural environment as closely as possible. Oxygen saturation is closely monitored. Too little oxygen can cause suffocation, while too much can cause gas bubble disease, a potentially fatal condition. From there, the journey continues on land. Large trucks fitted with insulated water tanks transport the live fish from the docks to the processing factory. These transport vehicles are a marvel in themselves, equipped with oxygen injection systems, temperature controls, and shock absorbers to ensure the salmon remain calm and healthy during the trip. Time is critical. The longer the fish spend out of water or stressed, the faster their quality deteriorates. Processing factories aim to receive live salmon within hours of harvest to maintain maximum freshness. Upon arrival, the salmon are stunned or humanely euthanized according to strict welfare regulations. Stunning methods vary, including percussive and electrical techniques designed to minimize suffering and prevent muscle damage. Fish that suffer trauma can develop dark flesh or a mushy texture, undesirable traits for any product on a shelf. Once euthanized, the fish are moved through an automated pre-processing line. High-pressure water jets and brushes clean off scales and slime, preparing the salmon for the next step. Automation speeds up this process, while maintaining hygiene standards far beyond what was possible just decades ago. From here, the salmon move through a series of conveyor belts, aligned perfectly to reduce handling and exposure to contaminants. Each fish is inspected, sorted, and prepared for butchering, ready for the next phase where technology and human skill combine to transform them into fillets. But before that, cold storage plays a vital role. The factory keeps the fish chilled at around 0 degrees Celsius, 32 degrees Fahrenheit, halting bacterial growth and preserving freshness until the cutting machines are ready. The salmon may have traveled thousands of miles from ocean cage to factory, but their journey isn't over. Next comes the most mesmerizing part: how these large, slippery fish are turned into boneless fillets with incredible speed and precision. From fish to fillet, the journey of salmon to your plate. When salmon arrive at the factory, chilled and ready, the transformation from whole fish to neatly packaged fillets begins. It's an impressive mix of robotics, engineering, and human skill working together with incredible speed. The first step is head and tail removal. High-precision cutters, calibrated to each fish's unique size, swoop in with surgical accuracy, slicing in seconds. This isn't just for speed. It helps maintain the fish's texture and presentation, key details for market appeal. From there, the salmon moves down conveyor belts to advanced filleting machines. Using lasers and real-time imaging, these machines map the anatomy of each fish, slicing along the backbone to produce 2 clean halves. But salmon are notorious for their tiny pin bones, which can ruin a bite if overlooked. That's where high-tech deboning machines step in, using sensors and mechanical tools to pluck out every last bone within seconds. Even with automation, human expertise is essential. Workers stationed along the line inspect each fillet, spotting imperfections that machines might miss. Their eyes and hands remain the final guardians of quality. Next comes trimming and edging. Machines refine the fillets, removing ragged edges and shaping them uniformly for packaging. Appearance matters. A clean, symmetrical fillet not only looks better, but also commands higher value. Fillets with blemishes or discoloration may be redirected for smoked, canned, or processed products. Once perfected, the salmon enters vacuum-sealed packaging. Removing oxygen locks and freshness, prevents freezer burn, and preserves the fish's delicate flavor. Many fillets are also flash frozen, rapidly chilled to prevent ice crystals from damaging texture. From here, the salmon is stored in cold warehouses before being shipped globally in refrigerated trucks or containers. Astonishingly, this entire process, from whole fish to sealed fillet, can take less than an hour in a modern plant. It's a seamless chain of biology, technology, and logistics designed to deliver salmon as fresh as possible to your plate. Why salmon is a superfood, and why it's controversial. Salmon isn't just delicious, it's one of the most nutrient-rich foods available. Packed with omega-3 fatty acids, vitamin B12, vitamin D, and high-quality protein, salmon supports heart health, sharpens brain function, reduces inflammation, and even promotes glowing skin. Doctors often recommend eating it twice a week for maximum benefit. But here's where the debate starts. Not all salmon is the same. Wild-caught salmon, roaming the oceans on a natural diet of smaller fish and krill, develops rich flavor and vibrant color naturally. Farm-raised salmon, however, often gets its pink hue from carotenoids added to feed. Critics argue that farmed salmon can contain higher fat levels and sometimes traces of antibiotics or pesticides used in crowded farming conditions. There's also concern about environmental impact, from waste runoff to escaped farmed fish threatening wild populations. The industry is responding with innovations. AI and IoT systems are also revolutionizing aquaculture, automatically adjusting feed, detecting disease before outbreaks, and improving efficiency while reducing reliance on antibiotics. Even with controversy, salmon remains a global favorite. Its versatility, sushi, sashimi, grilled steaks, smoked cuts, ensures it's a staple in kitchens worldwide. From the tiny fertilized eggs in dim hatchery trays to the high-tech sea cages monitored by AI, to the automated machines slicing and packaging each fillet, the journey of salmon from ocean or farm to plate is nothing short of remarkable. It's a story of innovation, science, and relentless precision. Behind every perfectly cut fillet lies countless hours of careful care, technological marvels, and complex logistics. So next time you savor salmon, remember the silent factory machines, the diligent workers, and the smart algorithms that made that meal possible. And with the industry pushing toward more sustainable and humane farming methods, the future of salmon looks as promising as the flavor on your fork. If this deep dive into the world of salmon fascinated you, don't forget to hit subscribe and check out our other videos revealing the secrets behind your favorite foods. What food factory should we explore next? Let us know in the comments below. Thanks for watching, and see you in the next video.